Hello everybody, Mr. Zonker here. I know it's going to be very emotionally difficult to make it through your math class without me there, but don't worry, I'm here in spirit and in voice. If you're not at lesson 4 in your Unit 3 workbook yet, turn there now. And today, let's compare proportional relationships. 4-1, what's the relationship? The equation y equals 4.2x could represent a variety of different situations. 1. Write a description of a situation represented by this equation. Decide what quantities, what is x and y going to represent in your situation. Then make a table and a graph that represent the situation. So this is my situation. Don't use this, you're going to have to make your own, but just listen up and you can get the idea. A frog jumps 4.2 feet every second. So I'm gonna let this seconds be represented by x, like this seconds over here, and I'm gonna let feet be represented by my y, and you can see I made my table here. We have that equation they gave us, that 4.2, y equals 4.2x, so that's our rate. And let's look at this situation here, and I'm going to make a graph and a table to represent what's going on. I've used that information to fill this out. For every 1 second, we know we jump 4.2 feet, and that's my rate. So if I can continue filling this table out, if I use 2, use that rate, 2 times 2.4, 2 times 4.2 is 8.4, 3 times 4.2 is 12.6, and 4 times 4.2 is 16.8. Let's take a look at this graph. I knew my y-axis, I wanted to be able to fit 16.8 feet. So I just made that so I could accommodate 20. So that'll fit that. And my x-axis, I wanted at least 4. So I gave myself a little bit extra on the x, going to 5, and a little bit extra on the y. Now I put 1 point on here, 4, 16.8, that's 4, 16.8. But if we check the other pieces of data from our table, those should match on our table as well, on our graph as well. I have 1, 4.2, 1, 4.2, 2, 8.4, 2, about 8.4. So yeah, this works out. Now your situation that you come up with can be anything. You could do maybe $4.2 for each hour you work. You might do 4.2 minutes every homework problem assigned for math class. Whatever you can think of, it's going to be very similar to this table because we use the same equation, but I want you to think of your own situation, make the table and graph. Moving on to 4-2, comparing two different representations. I'm going to read this, so read along, and as I go, if we underline something, underline it in your book as well. It might be important. Number 1. Elena babysits her neighbor's children. Her earnings are given by the equation y equals 8.40x. It's a pretty big deal when they give an equation. Let's underline that. Where x represents the number of hours she worked and y represents the amount of money she earns. Jada, on the other hand, earned $7 per hour mowing her neighbor's lawn. I'm going to underline Elena as well because that's going to match with our equation, 8.4x. And then Jada earns that $7 per hour mowing. Take a few minutes to read A, B, and C and do your best to answer those questions. Then we'll go over it together. Feel free to work with a partner. Now there's a few different ways to do this, so just because your way isn't my way doesn't mean you're incorrect. Let's look at A. Who makes more money after working 12 hours? How much more do they make? And explain how you know. Let's break this down one at a time. Let's start with Elena. We have this equation, y equals 8.40x. I'm going to put an E for Elena, and that rate there, using that equation, or our slope, is going to be $8.40 an hour. If we want to find out how much she earns after 12 hours, let's multiply that by 12. And that's kind of represented by our x here, $8.40 each hour for 12 hours. If we calculate that out, we're going to get $108.40. Now let's move on to Jada. We saw that Jada earns $7 per hour. So $7 for 12 hours, that's going to be 7, that rate, times 12, that's going to give us a total of $84. And I think we could see who makes more money. We might have guessed because Elena has a bigger rate than Jada. Elena's going to make more, and to find how much more, we can find the difference between these two numbers, 108.40 minus 84. That's that second part. How much more does Elena make than Jada? And then all of this work you can use as your explanation. Question B asks, what is the rate of change for each situation and what does it mean? Well, we kind of addressed that in the last problem already. We saw that based on this equation, Elena's rate of change is $8.40. She gets $8.40 an hour. We saw that Jada earns $7 per hour. That's that rate, $7 for every hour she mows. So use that info to answer question B in your workbook. For question C, it says, how long would it take each person to earn $150? Explain or show your reasoning. Well, we know that Elena's rate is $8.40. If we want to earn $150 total, we want to know how many hours it would take. If we take this 150 and divide it by $8.40, that's going to give us the number of hours. We can do the same thing for Jada, 150 divided by 7, and that'll give us the number of hours each needs to work. Because we know this times the number of hours, the rate times the hours equals the total money. So we can do the opposite, 150 divided by either of these to find that rate. Do that now, write your answer in your workbook. Moving on to number 2. Claire and Han have summer jobs stuffing envelopes for 2 different companies. Claire's earnings can be seen in the table. So here we've got our earnings for Claire. I'm going to just mark those so I know which one's talking about which. Then we see that Han earns $15 for every 300 envelopes that he finishes. Read questions A, B, and C and give it your best shot. Then we'll go over it together. Question A. Who would make more money after stuffing 1,500 envelopes? How much more money would they make? Explain how you know. This is kind of like that last problem we did. We should find the rate for each of Claire and Han. I'm going to start with Han. We know Han earns $15 every 300 envelopes. If we divide those, we're going to get the number he makes per one envelope. If I put that in my calculator, it looks like I get 0.05, which is about 5 cents each envelope. Moving on to Claire's table, there's a couple ways to go from here, but like we've been doing in class, we can find that rate by dividing our y and x values. $40, it looks like she will make 40 envelopes, it looks like she'll make $400. If we divide 40 by 400, it looks like we're going to get 0.1, I'll put a 0 in because it looks more like money, 10 cents. We could have also divided 90 by 900 to get the same thing. So there we go. We've got both of our rates. I've written them right up here. 0.05 for Han and 0.10 for Claire. So who makes more money after stuffing 1,500 envelopes? Well, we can tell it's definitely going to be Claire because she makes 10 cents per envelope compared to 5 cents. In fact, she should make double. But let's check it out just so we can find out exactly how much money they make. I've taken both of those rates. Han is 0.05, Claire is 0.10, multiplied the rates by the 1,500 envelopes to get $75 for Han and $150 for Claire. So it's confirmed. Claire definitely is making bank by stuffing these envelopes. In fact, she's making double what Han makes. Answer question A. Make sure you do all the different parts. Who would make more? How much more? And then your explanation could be all this work here. Looking at B, what is the rate of change for each situation and what does it mean? In answering A, we actually covered this. Look back at those rates you wrote down and answer this question. And for C, who gets paid more in their job? Explain or show your reasoning. Again, in figuring out number 1, it looks like we can also answer C. So do that now. What's that? Oh, you're having so much fun, you want one more? Oh, all right, I got you. Tyler plans to start a lemonade stand and is trying to perfect his recipe for lemonade. You go, Tyler. He wants to make sure that recipe doesn't use too much lemonade mix, which is lemon juice and sugar, but it still tastes good. That is important for lemonade. Lemonade recipe 1 is given by the equation y equals 4x. Hey, we've got an equation here. I'm just going to underline that so we can remember where that is. That's going to be important. Where x is the amount of lemonade mix in cups and y represents the amount of water in cups. It looks like lemonade recipe 2 is given by this table. I'm going to put a nice little box around that. So I have my 2 different situations. It looks like I've got an equation and a table. I bet they're going to ask us to compare these. I'll let you read A, B, and C and try your best. You can work with the partner again if you want to, and we'll go through it together after that. A, if Tyler has 16 cups of lemonade mix, how many cups of water would he need for each recipe? Explain how you know. We're going to have to use these rates. Let's start with this first one, y equals 4x. Y equals 4x. And x represents our cups of lemonade. So if I wanted to find how much water I need for 16 cups, I can use that rate of 4. Let's do 4, our rate, times 16. And that would give us a need for 64 cups of water for that recipe number 1. For recipe number 2, we need to take a look at this table. Now, none of my values have 16 cups, so we're going to need to add that value in. I'm going to just put that right on the bottom, 16. Now, to find what's missing, the amount of water to go with that, we're going to need to find our rate. So let's pick any of these. I'm going to pick this first one because it looks nice and easy and say 50 divided by 10. That would be 50 divided by 10, giving me a rate of 5 water cups per lemonade. If I take that rate, multiply by my 16, it looks like I'm going to get 80 cups of water. So that is the amount of water I would need for recipe number 2. B, like in the other problems, is asking us what is the rate of change for each situation and what does it mean. You should have written those down already if you didn't get them your first time around. So use those rates to answer this question. C is a little interesting though. Let's take a look. Tyler has a 5-gallon jug which holds 80 cups to use for his lemonade stand and 16 cups of lemonade. Which lemonade recipe should he use and explain? I've written down our rates with the amount of water needed for 16 cups like we found in part A. So for the first recipe, y equals 4x, we had 4 times 16 cups to get 64 cups of water. Our second situation, the table, recipe 2, we found that extra value 16 times the rate of 5 is equal to 80. Oh, well, that's that 80 that we want, 80 cups. But wait a second, is it really? This 80 actually only represents the water. We also need to account for the 16 cups of lemonade. That would give us a total of 96. 80 plus 16. What about recipe 1? We found we needed 64 cups of water for every 16 cups of lemonade. If I add those together, we get that perfect 80 cups. Whenever you start a lemonade stand, make sure you account not only for the cups of lemonade, but also the cups of water combined for your container. If you've made it this far, congratulations, you've reached the end. If you haven't made it this far, unfortunately, you will never hear this congratulations. But I hope that most of us have. Let's recap what we covered today. What do you need in order to compare two proportional relationships? Well, the main thing we found in every problem was the rate. And whether we get that rate through a table or an equation, those rates will help us compare the two different scenarios. What type of wording in a problem, statement, or description of a situation tells you that you have a rate of change? Well, there's a few different ways to do this. One is when you hear that word per, like dollars per hour, feet per second, whenever it's comparing directly two variables, two different things, that's a big clue. Of course, whenever we have our table or equation, those are very useful as well. How did you decide which representation to use to solve the different types of problems? Well, some types of situations are easier to graph, some are easier to make tables, some people like equations. Again, these are all different ways to represent the same thing. So there's not necessarily one right or wrong way to represent the situations as long as they're consistent with what's actually happening. How much do you agree with our learning target today? I can compare proportional relationships represented in different ways. Were you able to look at two different situations, use the rates, and decide who made more, which one needed more cups, etc., etc.? Time for the cool down. Head on over to joinpd.com, use your class code, and answer the question. Remember, make sure you answer each part, not just the first question. Don't forget, tonight you have the Lesson 4 practice problems for homework. You have homework hints on Google Classroom. Let me know if I can help in any way. Zonker out.